How do traffic lights at car intersections know when a vehicle is present?
Many traffic lights are triggered to change by the approach of a car. The principle is similar to the metal detector, in that there are coils of current carrying wire just below the road where the vehicles stop at the intersection. When a large enough amount of metal passes over the coil, it induces a change in the current that creates a signal in the electronic circuits that control the traffic light.
What happens to an element when it decays by emitting an alpha particle?
The nucleus that results from a radioactive decay is called the daughter. The number of nucleons in a radioactive decay does not change, and in an alpha decay the number of protons of the original must equal the number of protons in the daughter plus the number of protons in the alpha. The same is true for the number of neutrons. So, for example, when uranium-238, with 92 protons and 146 neutrons emits an alpha, the daughter has 90 protons and 144 neutrons. It is thorium-234. The alpha is emitted with a specific energy. Only very heavy nuclei decay by alpha decay.
How does a hydraulic lift work?
Pascal's principle states that pressure in a liquid is independent of direction. Pressure is force divided by area, so force exerted by a liquid is equal to the pressure times the area. A hydraulic lift has a small piston in a cylinder. If you exert a force on the piston, it will create a pressure in the fluid. The lift also has a second, large area cylinder and piston. The fluid creates a pressure in the cylinder that exerts a much larger force on the piston because of its larger area. Therefore, the lift has a mechanical advantage. Of course, energy is still conserved, so the small piston must move much farther than the large piston. An automobile lift, used in many automotive repair shops, allows the operator to use very little force to lift an automobile off the ground. By pushing liquid from a small diameter cylinder and piston through a thin tube that expands into a larger diameter cylinder and piston, which is located beneath the vehicle to be lifted. Since the liquid cannot be compressed like air, the liquid from the small cylinder is pushed into the large cylinder, forcing the large piston to move upward.
Why do we need to introduce momentum and energy? Aren't Newton's laws good enough?
Newton's laws could be used, but when you analyze the motion of more than a few interacting objects, Newton's laws are just too complicated. When you use momentum and energy, you concentrate on the beginning and end of an interaction. not on the details of the interaction. A sports team can be said to have momentum.
Why are many water towers placed on high towers?
The height of the water determines the pressure. Since a holding tank is up high, it places a lot of pressure on the water in the rest of the water network. The tank should be as large across as possible so that for the same amount of water the vertical dimension of the tank can be as small as practicable. This design limits the variation in pressure as the tank empties or is filled.
Why is the ocean blue?
There are two major reasons why the ocean and most bodies of water appear blue. The first can be observed by looking at the water on a cloudy day and then on a sunny day. There is a rather large difference in how blue the water appears to be on the two different days. Because the water acts as a mirror for the sky. So on a sunny day with a blue sky, the water will have a richer blue color than on a cloudy day. The second reason why bodies of water have a blue appearance is that water scatters short wavelength light more than the longer. In fact, water absorbs some orange, red, and the very long wavelength infrared. As a result, it absorbs more energy in the sunlight, increasing its temperature. The much larger amounts of reflected, short wavelength light results in a crisp blue-colored body of water. Some bodies of water may take on a more greenish or at times a brownish or black color. Usually this is due to other elements in the water such as algae, silt, and sand. Runoff water from glaciers is very white due to the tiny grains of silt in the water. Still, in the majority of cases, water looks blue.
What are Young's modulus?
Applied pressure, called stress, divided by the ratio of the change in length to the original length, called strain.
Does lightning always strike the ground?
Although most people think of lightning when it goes between Earth and clouds. The most common type of lightning occurs inside and between thunderclouds. It is usually easier for lightning to jump between the clouds than it is for it to jump from the clouds to Earth. As a result, only 1/4 of all lightning strikes actually strike the ground.
What is a ground fault interrupter, GFI?
Detects difference in current into and out of circuit to protect against accidental grounding, typically through water.
What is the string theory?
Proposed theory to replace the standard model. Each particle is a string, a tiny closed loop. Requires a 10-dimensional spacetime rather than the normal 4-dimensional one.
What is a light detector?
Converts light energy to another form of energy.
What would happen to Earth if the Sun suddenly disappeared? How soon would Earth recognize that the Sun's gravitational field was gone?
It couldn't happen instantaneously, because Einstein's special theory of relativity says that no information can travel faster than the speed of light. So, it would take about 8 minutes before Earth would both experience the lack of sunlight and the lack of gravitational force. Many scientists now believe that gravity is the result of mass warping space-time. While the effects of gravity have long been studied and its laws defined, what the force of gravity actually is still is a matter of debate.
What are gears and why are they simple machines?
Gears are toothed wheels which transmit torque between two shafts. The teeth prevent them from slipping, so they are called positive drives. The smaller gear in a pair is called a pinion and the larger one a gear. Because the teeth mesh, in a given amount of time, the number of teeth engaged on the pinion equals the number on the gear. The number of teeth is proportional to the circumference of the gear that, in turn, is proportional to the radius of the wheel. Therefore if the pinion makes one turn, the gear will make, repinion/regear, turns. Because energy is conserved, the torque exerted by the gear equals the torque applied to the pinion, regear/repinion. Gears are often used in an automatic transmission, converting the high speed, small torque output of the engine to the low speed, large torque output needed to turn the wheels. This kind of gear drive is called a step-down drive. On the other hand, in a windmill, the blades turn at a low speed but provide a large amount of torque. The gear drive in a windmill is a step-up drive. The electric generator, on the other hand, requires high speed, but can work with a smaller amount of torque. Gears also allow a bicyclist to match the speed with which she can rotate the pedal sprocket with the speed needed to drive the wheels.
What is the closest fusion reactor?
The Sun. In stars like the Sun, the principal reaction is called the proton-proton cycle. that was first described by the German-American physicist Hans Bethe. 1906 to 2005, in 1939. In the first step, two protons fuse into a deuterium, 2H, nucleus. The deuterium has a proton and a neutron, so the second proton changed into a neutron, releasing a positron and a neutrino. The positron annihilates with an electron, producing two gamma rays. In the second stage, the deuterium fuses with another proton to produce helium-3, 3He, plus a gamma ray. In the Sun, the third stage is primarily a fusion between two 3He nuclei producing 4He plus 2 protons. So the net reaction is an input of 4 protons and an output of 2 4He plus 6 gammas and 2 neutrinos, as well as a lot of energy due to the loss of 0.7% of the mass of the protons. In order to accomplish these reactions, the protons must be moving with a large amount of kinetic energy, the equivalent of a temperature of about 10 million kelvins.
What is a Coriolis force?
A pseudo-force that exists only in rotating reference frames. Apparent force in direction of rotation.
What is an electroscope?
A device used to measure electrical charge on an object.
What is a flavor?
Generation of quark, up/down, strange/charm, top/bottom, or lepton. Electron/electron neutrino, muon/muon neutrino, tau/tau neutrino.
What is a penumbra?
Area of a shadow where light from only part of the source is blocked.
What is an isotope?
Nuclei with the same number of protons but different numbers of neutrons.
How does a curved ball curve?
The curved ball experiences the Magnus force like the golf ball. The pitcher can give the ball a backward spin, creating lift, or a sideways spin, causing the ball to curve sideways. When a pitcher throws a knuckle ball, the ball spins very slowly. The laces on the ball create small forces that make the ball move erratically through the air.
What is a law?
Summary of many observations that describes phenomena.
What is fluid dynamics?
Fluid dynamics is the study of fluids in motion.
What is a hertz? Hertz.
Unit of measurement of frequency. Equals 1 cycle per second.
What is a scalar quantity?
A quantity that has only magnitude, size.
How fast does sound travel in different media?
A simple model that explains the main factors affecting the speed of sound is a collection of balls. Molecules, connected to each other by springs, bonds between molecules. Vibration from one ball will be transferred by the springs to neighboring balls, and in succession throughout the collection. The stiffer the springs and the lighter the balls, the faster the vibrations will be transferred. The springs are a model of the bulk elasticity, how the volume changes when the pressure on it changes. Of the material, the balls and their spacing model the density of the material. In general, the speed is slowest in gases, fastest in solids. Even though liquids and solids are about 1,000 times denser than gases. The greater elasticity of liquids and solids more than compensates for the larger density. In gases the speed depends on the kind of molecule and temperature. For air, the speed depends only on temperature. The following table illustrates some examples of the speed of sound in different media.
When tossed in the air, why do hammers wobble end over end?
In earlier chapters we considered only point objects. That is, an object so small that it could be thought of as the tiniest ball. Now we want to expand our considerations to large objects. First think of a baseball. If a baseball is tossed into the air, the ball follows a smooth parabolic path as described earlier in this book. If, however, a hammer is tossed, its path appears much more complex. Why? All objects are made of atoms. The mass of the object is the sum of the masses of all the atoms. And the force of gravity on each atom is proportional to the mass of that atom. In a baseball the center may be made of different materials than the surface, but if you ignore the laces, the ball is made up of the same materials regardless what the direction is. That is, the ball is spherically symmetric. The center of gravity in any object is defined as the average location of its weight. Because the mass is distributed evenly throughout a baseball. The center of gravity is located in the center of the ball. However, for an object such as a hammer, with a metal head and a wooden handle, the center of gravity is not directly in the middle. Since more mass is located in the metal head of the hammer, the center of gravity is closer to that point. The laws of physics state that the center of gravity follows a parabolic curve when tossed in the air. Indeed, although the ball and the hammer do not appear to have similar motions, their centers of gravity do. If you watch closely both the center of a baseball and the center of gravity of a hammer, you will see that they both follow parabolic paths when thrown. Because the force of gravity is proportional to the mass, the center of mass is at the same location as the center of gravity.
Why are polarized glasses useful?
Polarized glasses are useful when driving, sailing, skiing, or in any situation where unwanted glare is present. Glare is caused by light reflecting off a surface, such as water, a road, or snow. Such light is polarized. Navigating your way through some situations could be difficult without polarized sunglasses. Take, for example, light reflecting off the surface of a lake. The light polarized parallel to the water's surface is reflected with a greater intensity than that polarized perpendicular to the surface. So, sunglasses that pass vertically polarized light will reduce the glare from the water.
What is a Bernoulli effect?
One of three causes of lift. Due to difference in air pressure on upper and lower surfaces of wing.
What is acoustics?
Study of the ways musical instruments produce sounds, the design of concert halls, using ultrasound images.
Why do you feel an outward force on you when you are in circular motion?
When we introduced Newton's laws, we neglected to state an important warning. These laws work only in an inertial reference frame. That is a reference frame where there is no acceleration. A car, when it is speeding up, slowing down, or changing direction, is accelerating. Therefore, a person in the car experiences other forces. When the car is speeding up, you feel pushed back into the seat. When the car is slowing down, you feel yourself being pushed forward. When rounding a curve, you feel pushed outward. These are not real forces, but are often called inertial, fictitious, or pseudo-forces. For objects in circular motion, there are two such forces, The centrifugal and Coriolis forces. The centrifugal force is the fictitious outward force you feel when your car is rounding a curve.
What materials are used for static structures?
The first materials used were made of stone. Especially stones like flint that could be chipped to make sharp edges and points. Ancient peoples discovered metals, either in pure form, or in ore, that is mixed with non-metals. Copper, tin, gold, and iron were known before 2000 BCE. Copper, tin, and gold are very soft and not very useful as tools or weapons. A method of hardening metals is to mix two or more different metals forming what is called an alloy. Bronze is made by adding tin to copper and was known by about 4000 BCE. In what is now Iran and Iraq. The tin came from southern England. Bronze is a hard metal that can be melted and cast in various shapes, including statues. Today bronze is used for bells and cymbals. Not much later methods were found to convert iron ore, which is iron mixed with either oxygen or sulfur, to pure iron using a charcoal fire. Iron replaced bronze as a material for tools and weapons because it was cheaper and didn't require long trade routes to obtain the tin. To keep iron from being brittle, the carbon must be removed. If the iron is heated to red heat and then hammered, the carbon is forced to the surface where it can be removed. The result is steel that contains less than about 1% carbon. Steel is a versatile alloy of iron and carbon because additional materials can be added to change its properties. Very hard steel, called tool steel, contains tungsten, molybdenum, and chromium, among other minor additions. Its hardness can be changed by heating it and then cooling it very quickly by quenching it in water or other liquids. Stainless steel used in knives, forks, and spoons has 18% chromium and 10% nickel. Other stainless steels use different amounts of these two metals as well as molybdenum and magnesium. Stainless steel does not rust, but isn't as hard as tool steel. Pewter is a tin alloy that was developed in England for plates and cups. It adds copper, bismuth, and antimony to tin. Originally lead was used, but because it is poisonous, it is no longer found in pewter. Brass is typically 80% to 90% copper with zinc added. Actually, brass was made before metallic zinc was isolated. The zinc or calamine was melted with copper. Brass is used as a decorative metal as well as in bullet casings. If aluminium and tin are added, it is resistant to corrosion by seawater. Gold is another very soft metal. It can be made harder by adding copper and silver in equal quantities. Gold alloys are measured in carats. 24-karat gold is pure gold, while 18-karat gold has 18 parts gold and 6 parts other metals. 10 carat gold has 10 parts gold and 14 parts other metals. Titanium is used in many alloys today because it is lightweight and corrosion resistant. Many alloys of both metals and nonmetals are used in electronics. Some LED lamps contain the metals gallium and aluminium and the nonmetal arsenic.
Why do astronomers believe there is dark matter in the universe?
The first hints that there is more to the universe than visible stars and galaxies came in 1933 when the Swiss-American astronomer Fred Zwicky, 1898–1974, studied the motion of galaxies in the Coma cluster and estimated that in order to account for their rapid motion there must be 400 times as much mass as could be accounted for. In the 1970s the American astronomer Vera Rubin, 1938, studied the rotation of galaxies and found that at least half of the matter in galaxies must be invisible dark matter. Dark matter is also in evidence in gravitational lensing, where the gravitational interaction of mass with light causes the light from very distant galaxies to be bent by nearer galaxies. The result is a distortion of shape and position in the images of the distant galaxies as if they are being seen through a lens. In one set of colliding galaxies the center of mass, determined by the lensing effect, is separated from the center of optical and X-ray brightness, probably by the effect of the collisions. Radio and infrared emissions from the initial Big Bang that formed the universe is called the 3 Kelvin cosmic microwave background radiation. Understanding the details of this radiation also requires large amounts of dark matter.
What is a diffuse reflection?
Light rays reflect into different, random directions, as from paper.
How then does a one-way mirror work?
First, the mirror isn't totally reflecting. It transmits half the light and reflects the other half. The second requirement has to do with lighting. It is imperative that the observation room remain dark, because if a lamp were turned on, some of that light would pass through into the interrogation room as well.
Does the United States use SI?
Although the American scientific community uses the SI system of measurement, the general American public still uses the traditional English system of measurement. In an effort to change over to the metric system, the United States government instituted the Metric Conversion Act in 1975. Although the act committed the United States to increasing the use of the metric system, it was on a voluntary basis only. The Omnibus Trade and Competitiveness Act of 1988 required all federal agencies to adopt the metric system in their business dealings by 1992. Therefore, all companies that held government contracts had to convert to metric. Although approximately 60% of American corporations manufacture metric products, the English system still is the predominant system of measurement in the United States.
What is a wave velocity?
Depends upon the material or medium in which it is traveling.
What is a compass?
Magnetized pointed metallic pointer that can rotate about a low friction pivot point.
How does air drag affect the motion of dropped objects?
Air drag adds a second force exerted on the object that is in the direction opposite its motion. The net force is the difference between the downward force of gravity and the upward force of air. As was discussed above, the force of the air increases as the speed increases. Therefore, as the object falls and gains speed, the upward force increases. At some time it will equal the downward force and there will be no net force on the object. So, according to Newton's first law, the object's speed will now become constant. This constant velocity is called the terminal velocity.
What are beta particles?
Electrons emitted at high energy by some radioactive nuclei.
What is a concave mirror and what is it used for?
A concave mirror is curved inward so that the incident rays of light are reflected and can be brought together. If the rays striking the mirror were parallel to each other, as they would be from a distant source, then the reflected rays converge at the focal point. Concave mirrors are typically used to focus waves, whether it is a microwave signal to a receiver or light to an observer. They can produce real images. If, however, the object is closer to the mirror than the focal point. As is often the case with a concave bathroom mirror, the image is virtual and upright. If you look at the reflection of a more distant object, like the bathroom wall, you'll notice that it is upside down, or inverted. The wall is farther away from the mirror than the focal point, and its image is real. A point. Therefore convex mirrors form virtual images. Convex mirrors are used for security purposes in stores because they broaden the reflected field of vision, allowing clerks to see a large section of the store. The images are smaller than the objects, but the mirrors help to see a wide area.
What are brittle materials?
Usually break when under tension rather than compression.
What is a fusion?
Joining of two nuclei to form a more massive nucleus.
What do some of the metric prefixes represent?
Prefixes in the metric system are used to denote powers of 10. The value of the exponent next to the number 10 represents the number of places the decimal should be moved to the right. If the number is positive, or to the left, if the number is negative. The following is a list of prefixes commonly used in the metric system. Sundials are a very old way to tell time. While accurate, they are limited by the fact that they only work when the sun is shining.
What do radio astronomers hear?
Radio astronomers detect what sounds like noise, but is actually signals from atoms, molecules, and ions in stars, galaxies, and particles in interstellar and intergalactic space. In order to detect these signals, radio telescopes are used. These are shaped like large satellite dishes, and are able to detect wavelengths between 1 mm and 1 km.
What is the Archimedes principle?
An object immersed in a fluid will experience a buoyant force equal to the weight of the displaced fluid.
What speed would a stationary observer measure?
Surprisingly, she would find that the light was traveling at the speed of light. Not the sum of the speed of the spaceship and the speed of the laser light as measured by the traveling person. That is, the speed of light is the same in all frames of reference. This is another of the results of Einstein's special theory of relativity. It has been tested, not with spaceships, but with gamma rays emitted by subatomic particles moving near the speed of light.
What is a Fourier theorem?
Any repetitive waveform can be constructed from a series of waves of specific frequencies, of fundamental and higher harmonics.
What is a torque? T.
Equivalent of force for rotational motion. If forces is at a right angle to the radius, then torque equals the force times the distance from the axis of rotation.
What was the first type of bridge?
The first type of bridge ever used was a beam bridge. This bridge was probably just a fallen tree that was used to cross a ravine or a small stream. The tree was probably supported by the riverbed or by a group of rocks. Beam bridges consist of a horizontal roadbed supported by vertical piers on the shores that are planted in the ground. Beam bridges are limited by the resistance of the roadbed to bending.
How do we see objects?
In order to see an object, light from the object must enter our eyes. We can see stars, lightning, and light bulbs because they are emitting or giving off light. We depend on the light emitted from these sources in order to see objects that don't emit light. We see those objects because they reflect light into our eyes. The paper on which this book is printed, for example, does not emit light. We see it because the paper reflects light into our eyes.
What is a Leyden jar?
Device consisting of an insulating jar with conductors on inner and outer surfaces. Stores charges. Modern version is a capacitor.
What is hydraulics?
Hydraulics deals with the use of liquid in motion, usually in a device such as a machine. Oil is the most common liquid used in pumps, lifts, and shock absorbers.
How do skydivers and parachutists use air drag to control their speed?
Skydivers can change their body shape, and thus their terminal velocity, by extending their arms, or separating their legs. Parachutists can tilt the chutes to control the direction in which they're falling.
What is a current, electrical?
The flow of electric charge.
What is a critical mass?
Minimal mass of enriched uranium or plutonium needed to create a bomb.
What is the refractive index, N?
Ratio of speed of light in a vacuum to that in a medium.
Why is it easy to tip over some objects?
If you want to tip something over, you'll have to rotate it. As you have seen, rotation means you need to apply a torque. An object sitting on a surface has several forces on it. First, is the gravitational force that acts on its center of gravity. Second, is the upward force of the surface. Third, is friction between the object and the surface that exists only if the surface is on a slant. Now suppose you exert a sideways force near the top of a box. That creates a torque and the box begins to rotate.
What is harmonic?
Mode of vibration that is a whole number multiple of the fundamental mode. The first harmonic is the fundamental frequency. The second harmonic is twice its frequency, etc.
What is a GFI, or ground fault interrupter?
A ground fault interrupt outlet is now required by building codes for outlets within 6 feet of a sink or in any other environment where water could be close to the outlet. Normally the currents in the black and white wires will be equal. But if the water provides an alternative current path, then the two currents will no longer be the same. The GFI detects this difference and shuts off the circuit within milliseconds. GFIs should be tested periodically to make sure the electronic circuit is still working.
What is lightning and how is it created?
Lightning is an electrical discharge in the atmosphere, like a giant spark. There is still debate about the cause of the separation of charges needed to create the discharge. Atmospheric scientists believe that strong updrafts in the clouds sweep droplets of water upward, cooling them far below the freezing point. When the droplets collide with ice crystals, the droplets become a soft mixture of water and ice. As a result of these collisions, the ice crystals become slightly positively charged and the water/ice mixture becomes negatively charged. The updrafts push the ice crystals up higher, creating a positively charged cloud top. The heavier water/ice mixture falls, making the lower part of the clouds negatively charged. The ground under the cloud is charged by induction. The buildup of negative charges on the underside of a thundercloud attracts the positive charges in the ground. The negative charges are repelled further into the ground, leaving a positively charged surface.
When are fusion reactors expected to generate electricity?
No one knows, but the prediction of scientists working on fusion projects that has been made every year since the 1960s is about 40 years from now.
Why do electricians work with one hand behind their back?
When working on high voltage circuitry, many electricians like to place one hand behind their back because this way there is little chance for each hand to touch objects of different electrical potentials and cause a shock.
What is physics?
The study of the structure of the natural world that seeks to explain natural phenomena in terms of a comprehensive theoretical structure in mathematical form, from the Greek physis, meaning nature.
Does a gas or a liquid exert a friction-like force?
If you stick your hand out of the window of a moving car, you can explore the properties of air drag. The faster you go, the stronger the force. If your palm is facing up or down, the drag is much smaller than when your palm faces forward or backward, showing that the shape of the object matters. A smaller hand experiences less drag than a larger one. So, drag depends on velocity, area, shape, and the density of the air. These properties are different from other contact friction forces. But the force is still exerted in the direction opposite motion, so it slows down the object. Liquids exert similar, but stronger, drag forces.
Who invented the electric light bulb?
The first person to generate light from a wire filament was the British Sir Humphrey Davy. Davy was known for his work on electric arc lamps in the early 1800s. And his breakthrough discovery was the first electric light. His lamp used a very thin piece of platinum wire that had high resistance and emitted a soft glow. The lamp didn't last long, and so it was not practical, but it did pave the way for others.
How do the numbers of protons and neutrons in nuclei compare?
For lighter elements, the number of protons and neutrons are approximately equal. For example, the most common isotope of helium with 2 protons is 4He, so it has 4 to 2 equals 2 neutrons. Oxygen, with 8 protons, has 8 neutrons in its most common isotope, 16O. In elements heavier than calcium, 20 protons, 20 neutrons. The number of neutrons is larger than the number of protons. In uranium-238, 92 protons, 146 neutrons, the ratio is almost 3 neutrons for 2 protons.
How has radar been used in astronomy?
In radar astronomy, electromagnetic waves are aimed at planets. By analyzing the reflected signals, the position, velocity, and shape of objects in our solar system can be determined. In the early 1960s, radar was used to determine the exact distance between Earth and Venus and Earth and Jupiter. Later, radar was installed on the space probe Magellan to map the surface of Venus. Radar astronomy has been beneficial in determining distances in our own solar system. But the reflected signals would be much too weak from objects outside our solar system.
What is a kilohertz? Kilohertz.
(1000 Hz).
What is a charging by contact?
Results when a neutral object touches a charged object.
What is color blindness?
An inability to see some colors due to an inherited condition.
What are some other places where hydraulic lifts are used?
Besides their valuable use in auto repair shops, hydraulic lifts are used in elevating crane and backhoe arms, adjusting flaps on airplanes, and applying brakes in automobiles. It is the non-compressible characteristics of liquids that make hydraulic devices so useful. Oil is used rather than water because it does not freeze. This heavy crane boom uses hydraulics to lift the boom.
How dark can it get on Earth during a solar eclipse?
Some observers reported that they saw Venus and some of the brighter stars during a total solar eclipse. It is not entirely dark, however, because light comes from the sun's corona. The extremely faint glow surrounding the sun that is produced by ionized gases emitted by the sun. More light may come from reflection of light by the atmosphere in nearby areas not in the path of totality. The complete eclipse of the sun lasts for an average of about 2.5 minutes, but can last over 7 minutes.
Can the size of umbras and penumbras change?
An umbra and penumbra exist wherever there are shadows produced by a large light source. When an opaque object casts a shadow on a surface close to it, the shadow will be clear and distinct. Because it has a large umbra section and small penumbra. If, however, the object casting the shadow is closer to the light source, there will be regions on the surface where light from some of the source is not blocked by the object, producing a smaller umbra and a larger penumbra. A lunar eclipse occurs when the Earth is directly between the Moon and the Sun.
Can a temperature be measured without contacting the object?
As was described in the chapter on energy, when an object is hot it transfers energy to colder objects. If it is in contact with the other object, the transfer is by means of conduction. But all objects at temperatures above absolute zero radiate electromagnetic waves in the infrared part of the spectrum. See the chapter on waves for a description of the spectrum. A hotter object radiates more energy this way. And so there will be a net transfer of energy from the hot object to cold objects around it. An electronic sensor can detect the infrared radiation and convert the amount and wavelength of radiation it receives to a temperature. The sensors can be built into cameras that create a picture that shows the temperature of every location in the picture. Such a picture is known as a thermograph. An electronic thermometer within the thermostat in your home or office triggers a switch that turns your furnace on or off, according to the temperature.
What makes a fluid flow?
As in all of physics, objects move as a result of a net force. In a fluid, the net force comes about because there is a difference in pressure between 2 points. The fluid flows in the direction of decreasing pressure.
What is an arrow of time?
The forward direction of time is the one in which entropy increases or remains the same.
What is a diverging lens?
A diverging lens has at least one concave side. The shape of the lens causes the entering light rays to spread apart when they leave the lens. A diverging lens is often used in combination with converging lenses. Eyeglasses to correct nearsightedness use diverging lenses.
What are maglev trains?
Maglev, or magnetically levitated trains, are different from conventional trains in that they use electromagnetic forces to lift the cars off the track and propel them along thin magnetic tracks. Some demonstration trains have reached speeds of 500 km per hour, 300 miles per hour. Although the United States has no maglev train, nor an active research program in this technology, Germany and Japan have conducted a great deal of research in the field.
Why does a stone sink but wood float?
A stone is more dense than water. That is, if you compare the mass of a stone to the mass of the same volume of water, the stone's mass will be greater. Therefore its weight will also be greater, so a stone, weighter will be positive. And there will be a downward net force. Therefore the stone will move downward through the water until it rests on the bottom. Wood, on the other hand, is less dense than water. If the wood is pushed under water, weighter will be negative. There will be an upward force on the wood and it will rise.
Why did Chuck Yeager go to such a high altitude to break the sound barrier?
Sound travels approximately 760 miles per hour in the warm, dense air found close to sea level. The cooler and less dense air is, however, the lower the speed of sound. Since air is less dense at higher elevations, physicists and engineers felt it would be easier to break the sound barrier at those elevations. Knowing the temperature and density of the air at 12,192 meters, 40,000 feet, above sea level, scientists determined that the speed of sound would be reduced to only 660 miles per hour. As an added bonus, engineers found that not only was the speed of sound slower at such elevations, but when the air has such low density, the parasitic drag, the drag due to friction, is very low as well. Therefore, to break the sound barrier, Yeager traveled as far up as 13,106 meters. 43,000 feet, above sea level to both reduce the sound barrier and decrease the parasitic drag.
What is gravitational field energy?
Energy stored in the gravitational field when an object moves away from the larger object that is attracting it.
What is next-red Doppler radar?
NextRad, or Next Generation Weather Radar, is one of the most recent technological breakthroughs for weather forecasting. NextRad relies on the Doppler effect to calculate the position and the velocity of precipitation. The spherical NextRad radar tower emits radar waves 360 degrees around and calculates the frequency shift of the reflected radar waves off rain, sleet, and snow. The NextRad computers then translate the information and represent The possible weather problems on a color-coded map for analysis. The maps are readily available in real time over the web. The goal and main function of NexRad precision radar is to save American money and lives. By predicting threatening weather problems and warning the public before tragedy strikes. Meteorologists estimate that this new tool for weather forecasting has saved millions of dollars and many lives through its early warning systems. One of the most impressive advancements has been in pinpointing tornadoes and hurricanes more accurately than what was possible before NexRad. Each NexRad station scans a radius of 125 miles with excellent accuracy, and less accurately up to 200 miles. A new system, developed since 1994, is Terminal Doppler Weather Radar, or TDWR. This system, installed at 45 airports, uses radar waves with 5 cm wavelength rather than the 10 cm, 3.9 inches, used in standard weather radar. As a result, it can resolve objects with twice as much detail, permitting it to detect wind shear and microbursts. Its range, however, is half that of NexRad, and it can see through heavy rain. Radar images are available to the public at www.radar.weather.gov.
What are Newton's laws of motion?
You have just explored how force and mass affect acceleration. Sir Isaac Newton, 1642 to 1727, summarized these results in what is called Newton's second law of motion. For a single force, like you used, it can be written as acceleration is equal to the force applied divided by the mass, or A equals F/m. That is, the acceleration, A, varies directly with the force applied, F. The stronger the force, the greater the acceleration. And it varies inversely with the mass, m. The larger the mass, the smaller the acceleration.
What is nearsightedness and what can be done to correct it?
Nearsighted vision means that a person can only clearly see objects that are relatively near the eye. Images from distant objects are focused in front of the retina. Nearsightedness, or myopia, is most often caused by a cornea that bulges out too much. The lens cannot be flattened enough to compensate, and so distant objects appear fuzzy. To correct for the short focal length of the lens, a concave lens is used to make the light rays diverge just enough so that the image will fall on the retina. So contact lenses to correct for myopia are thicker at the edges than at the center.